We can see the dust come in on the gust front ahead of the spring storms. When the winds blow out of the southwest and they bring the dust out of the desert, we can see it come in on the air. And then it's readily observed on the snowpack. The snow turns red or brown depending on the source area. And it's easy to see the dust on top of the snow. In our field observations, we've seen the effects of dust melting snow faster. And we've, in previous work, shown that dust causes the snowpack to melt out about a month early. So our next question was, well, what happens basin-wide, and what are the effects on runoff in the Colorado River?
So the Colorado River is the lifeblood of the American Southwest. It supplies water to almost 30 million people in parts of 7 different states. It irrigates 3.5 million acres in the American Southwest. Without the Colorado River, the American Southwest really is no more as we know it.
To accomplish our current study, we used a hydrology model which simulates the energy and water balance over the snowpack for the entire river basin. We compared 2 scenarios, one that represents current conditions, current dusty conditions, and another scenario which represents much cleaner conditions that existed before human settlement in this region. The effects of dust on snowmelt are actually readily observed. In fact, commonly we will scrape the snow surface free of dust and come back in the afternoon, and the dusty snow around that little patch will have melted faster, and we see a sort of elevated patch of snow where we scraped it clean. So one way we observe dust in the field is to dig snow pits, and we can see in those snow pit walls horizontal dust layers, orange or brown layers, that correspond to each of the dust deposition events that happened during that snow year. Our model results indicate that snowmelt has advanced on the order of 3 weeks. We see a 3-week shift in the peak of the snowmelt hydrograph. And because of that shift, we see on average a 5% reduction in river flow as measured at Lee's Ferry.
So the implications of the study are interesting with respect to what is happening now and what will happen in the future. With respect to what's going on now, I think that there's the opportunity potentially to recover some of the loss in water that's here by better land management in the American Southwest. Looking forward into the future, I think this study gives us some hints that we could lose yet even more water if we're not careful about how we manage those lands. One of the findings of this study is that on average we've lost 5% of the flow of the Colorado River. 750,000 acre feet, 750,000 acre feet. That's twice what Las Vegas's water right is right now. It's about half of what Arizona takes down through its Central Arizona project. It's twice what the city of Denver uses for water. It's a large chunk of water.
So our current effort is really trying to capture the entire dust on snow phenomenon. So we're using observations and models in the drylands regions to try to model and explore the phenomenon of dust emission in the first place, incorporating mesoscale weather models to simulate the synoptic weather environment and transport that dust, high resolution point snowpack models to put that dust into the snowpack and simulate its effect, and then coupling all of that with the regional hydrology models. So we're building this observation and modeling system using ground assets, satellite assets for observation, and then a full cycle modeling effort to really try to capture this whole system and try to explore what it might look like under future climates, under different land use regimes, etc. Our current work is focused on the Colorado River Basin specifically, but the dust on snow phenomenon occurs anywhere that there's mountains downwind of desert landscapes or dryland landscapes. We've seen both in study results and anecdotally that dust production from drylands is on the rise worldwide, and we're seeing impacts on mountain snow covers and glaciers in regions such as the Tian Shan in China and the Himalaya, The Antarctic Peninsula is seeing dust deposition coming from southern South America. And there's other mountain regions around the world that see this phenomenon. So this study, while the numbers we produce may not be directly applicable to these other regions, the phenomenon and the science certainly is, and we look to expand the sites that we can look at globally.